Hello, for this session we're going to begin creating our subassembly using some of the basic tools within Subassembly Composer. So as a reminder, let's look at the subassembly we're about to build. We've sketched it out, we understand what we need to do. We have placed all the parameters in the input-output parameters, so now we're ready to add the geometry. So let's jump over to Subassembly Composer and get this thing built. Okay, so we're now here in Subassembly Composer. Under the packet settings, you can see that we have the packet settings set up, input-output parameters, and the target parameters. Previously set that up. That way we're just ready to go and build this subassembly. So here on the left, we have our toolbox, geometry, advanced geometry, auxiliary, workflow, and miscellaneous. We're going to focus this first portion on the geometry, the three basic uses. So I'm going to take my point. This is going to be our starting point. I'm going to select it from the left. I'm just going to simply hold it, drag it, and drop it under start. It's going to give me a starting point, the origin point. Here on the properties, you can see now how that's populated. We have a point number and we have point codes. So in Civil 3D, to build our surface to extract data from, we want to make sure that's coded. And we're going to put that in there. This first one is going to be top. So we're going to put quotation mark, top. Okay. Point geometry type, we'll get more into that. There's multiple types in here. Point geometry properties, this is our beginning point, our starting point. And so we're going to leave this one as origin. We have a link. As we'll create these additional points, we're going to create some links as well. Name, codes, apply axis of rotation, and any miscellaneous comments. So the first thing you always want to do is you get that origin point or that starting point. You can see here in our preview, it's going to begin to create that subassembly. So I'm going to take point again. I'm going to drag it under P1 this time. And what that does is create a second point. So now we have P2 and L1 or link 1. And now we have to tell this what this one is. We're going to go from P1, a change in delta X or a change in delta Y. So this first one we're going to do is our planter area. So under the input-output parameters, this is where we could key in a value here. You know, if I just put in 5 for a change in Y, you can see it created that P2. If I change that back to 0 and let's put in 8 here for a delta X, you can see it now went from P1 to P2 with an 8-foot distance. We don't want to use just solid hard numbers here though. We want to use our input-output parameters. That way it's more functionable when we get into Civil 3D. So I'm going to change that back to 0. So our type here is a change in delta X and delta Y. As we go through, we got slope in delta X, slope in delta Y, slope to surface. That's the different types of points. So most common, you're probably going to use delta X and delta Y. But I'm going to give this, here we have planter width in our input-output parameters. I'm just going to simply do a Control C or a copy and paste. And I'm going to put that in my change in delta X. Okay. That way it gives us the ability to change that property in Civil 3D and have that more of a dynamic subassembly. But in this case, I want to do half of delta X because we're doing a swell in the center of that. And so I'm going to do a little bit of math here, or put a formula in here. I'm going to say delta X equals the planter width divided by 2. So whatever that planter width is in Civil 3D, if you change it from 8 to 10 to 12, for example, it's always going to be half the width, and that flow line is going to be centered in that planter. So let's go back here. We also have a change in delta Y. So we want to have that swell to our flow line, or our planter depth, as we call it in our input-output parameters. So I'm going to copy over planter depth. And I'm going to place it in here, and I want to show you, I'm going to zoom in here on my right in my preview. I'm going to just simply copy and paste in the planter depth. In this case though, you see how the planter depth increased, so it went up. we want to make sure that in cases where we want to go down, we're going to do negative planter depth. That way in Civil 3D, when we put in 3 inches or 6 inches or a foot, it's going to go down instead of up. So negative planter depth. Okay. We can also add in a point code here. So I'm going to double code this. I'm going to say top and FL for flow line. Okay. If you do put in something and Subassembly Composer doesn't like it, it's going to warn you. It's going to say the code is not valid, or you put it in improperly. What you have to do here, you see how I put both in quotes? You have to put each individual one in a quotation. Okay. So now we're good. So all I did was top quotation with a space between them, flow line. So I can double code that point. And same thing with the link. I could add a link here of, now let's call it planter. Okay, so let's continue on. Let's add our additional point here. Always got to remember the quotations. So now we're going to go to P3. P3 is going to be very similar to P2. So let's call that top. And what we're going to put in here is we're going to change in delta X. So again, we're going to have our planter width. Copy and paste it. Divided by 2. Now our delta Y, which is going to be our planter depth again. And this one I'm going to leave positive because it's going to go back up. Okay, so you can see that swell being created. Let's continue on now. Let's put our sidewalk in. So we're going to be working with a lot of points on this initial one. So I'm going to grab my point, drag and drop it. P4. P4 is going to be sidewalk, so I'm just going to, we'll just call it sidewalk or top, maybe both. Delta X is going to be sidewalk width. Delta Y is going to be based on a sidewalk slope. Okay, so we've got to change sidewalk width, so our default value of 5, and a change in the Y of the sidewalk slope, so at 2%. Code, we're going to call this, we'll call it concrete for our link, and we'll just keep moving on here. We want another point, so let's go add another point. This one's P5, so maybe we change this up. We want to start from P3, and we're going to give it the sidewalk depth. So again, I'm just copying here on the right, sidewalk depth, and I'm going to say a negative sidewalk depth. Okay, let's zoom in here a little bit so you can see. Okay, so we have, again, a 0 change in delta X, so it's just straight down for our sidewalk depth, and a negative change for delta Y in the depth of our sidewalk. Okay. Again, you can always code it here, so maybe we code this one datum. That'll give us the bottom of that. And then let's do another point. I'm going to change this to P4. So you can see here on the right, P4, a 0 change in delta X, sidewalk depth, a negative change in delta Y. Okay, so now it's coming together. We can code that as well. Let's see what we coded that before, so we just called that datum. And then maybe we just add a link in there. So we've been using points. Maybe we just grab and add a link. Okay, and that link, we tell it what it is. It goes from, we're going to go from P5 to P6. And you can see how that just closed up the object on the right side. We'll come back to that closed object. We'll add a shape for quantity takeoff purposes. Okay, so let's add a couple more. We're almost done with this one. We're going to add point. And I'm going to start this from P5. And this is going to be our subbase depth. So another change in y. So 0x, negative y. Okay. Point codes, we could call it subbase. Back to that. You'll see here how it's not linked P5 to P6, P7. If you do see that, there's a simple add link to point, and it's going to add that link in, and you can code that link as well. Okay, so if it doesn't do it for you, two ways. Automatically have it, add link from point, which is the easiest way, or add a link using the geometry tools in Subassembly Composer. Okay, so we're going to add another link here. We're going to go this time from P6. In the same fashion, we're going to do a negative subbase depth. Perfect. Let's add our link in there. We're almost done here. And you can reorganize these as we get down to some more advanced videos. We're going to look at different ways of organizing our flowchart. If you can imagine, 100 different codes in here, it could get pretty interesting. So we are going to look at ways to manage that flowchart and that subassembly better. So we added that link, and it's going to go from P7 to P8. Link code, we'll call it subbase, or maybe it's bottom subbase. Okay. Almost done. Just a couple more items here on this first subassembly. We're going to add another point, and it's going to be a delta change in X and Y. Point code, let's call it top. Delta X is going to be our back of walk or a boulevard width behind the back of walk. So we're going to change that in delta X. And this is going to go from P4 okay. And again, we could either create a link to it, or let's just make sure we have selected our link. Okay. And we could add a slope in here if we wanted to. Right now we have it at a 0%, changing between P4 and P9. We could add another parameter. So if you're working through that assembly and you realize you need to have another parameter, all you have to do is come here to the input-output parameters. Let's say create parameter. We're going to do a grade, and we're going to call it the boulevard slope with a default value. Let's just say 5% on that one, just so it shows up a little bit better. So I'm going to copy boulevard slope, and I'm going to make sure I'm on P9, that very last code, and that's going to be a change in delta Y of boulevard slope, and you can see how that sloped up. Okay, so if we zoom out a little bit and you see that full assembly, again, this could have been built in Civil 3D with several different subassemblies. We now have one complete subassembly, dynamic, that we can use. We have everything coded, we have our links in there, but for quantity takeoff purposes, we want to have shapes. That's what QTO, quantity takeoff, will calculate areas by. So here under geometry, we've used point, we've used link, we now want to use shape. So I'm going to grab that and I'm going to drag it down here below P9. It's going to give us a little warning symbol for just a moment. Here under the shape code, the first one we're going to do is the sidewalk or concrete. So I'm going to call it concrete. Okay. We can either choose to select the links, add them all individually, or this green icon here allows me to select the shape. And as I hover over it, you can see how it identifies a closed object. So I'm going to pick that top one. And it's now concrete. One more shape. This one we're going to call subbase. Add that shape and pick the subbase. Okay. So all within a matter of minutes, we had our input-output parameters set up. We have created our first subassembly, fairly basic subassembly built out of points, links, and shapes, but it's now fully functionable, can be brought into Civil 3D, utilized in Civil 3D. So we're going to look at a couple additional ones coming up with some more advanced geometry, utilizing some of the advanced geometry, and then we'll get into more detailed ways of utilizing the workflow and flowcharts and so forth.